So I wanted to give you a couple of other pictures, but rather than just draw them on the board, I wanted to draw them with the computer. So let me do this. There we go. Great. So here's Desmos. The first one I wanted to look at was a function, which is kind of interesting. It's sine x divided by x. Very nice, right? Pretty function. Talk a lot about that. What I was interested in is what's actually going on here at x equals 0, okay? Because if you put in 0 here, right, I'm going to end up with sine of 0 over 0. So this is another 0 over 0 situation. So it's not defined here. In fact, I should have a hole there, but Desmos doesn't know. No, I'm not going to do the hole. But if I draw this myself, I have to draw a hole there because 0 is not in the domain of this function. But look what happens if I zoom in. Yeah, well, not like that. I'm trying to zoom really, really close in here. And your book sort of does this, but they do it with a table of values. They go really, really small numbers, really, really small. Whoops. Where's my real? Okay, so for sure, it's never going to put your hole there, right? But these are very small values. And as close as I like, it sure looks like it's going to 1. And we will prove that later at some point. There's a couple of ways to prove it. You're going to do it geometrically. Later you can do it with calculus. But it's certainly not at all obvious that it would be so. It's not obvious in the same way as when we did the example with the rational function and we saw that the x minus 1 canceled out. That was sort of obvious because it cancels out. Here, it's not that obvious what would cancel out here, and why that necessarily should be 1. All right, so let me zoom out a little more. Okay, so I'm going to look at a different function now, also though involving sine. I'm going to put pi over x here. This is a wacky one, right? So here, like what the heck is this? If I, like what is it even doing, right? So let's do the same thing. Let's zoom in. Zoom, zoom, zoom. Oh, come on. You can do this on your own calculator too. If I zoom in, no matter how much I zoom in, now I'm my y value. Why are you not doing that to me? Ugh, come on. Stop it. Stop it. It's stuck. It's stuck. Oh, no. Well, you can do this yourself because obviously I'm not doing a good job of it. Okay. But what's actually happening here? Let me stop the screen share for a minute. So what's actually happening is this. Right? The x is in the bottom. Okay? And as the x goes closer and closer to 0, you're getting something here which is going, you know, basically kind of bigger and bigger. So it's like you're taking the reciprocal of your sine curve and squashing it down. So what this function is doing, actually, as I get closer and closer to 0, it's just oscillating faster and faster. I can put a line there, right? Because, or rather not a line, a open circle, because it's not defined. But not only is it not defined, but the limit's not defined because there's nothing I can define in there to sort of to make it go to a specific value. Unlike my other function, sine x over x, was basically clearly both sides were going to 1. On this one, they're going everywhere, right? anytime, so if I think about that, right? As x goes to 0, right? I can go to 0 in different ways, right? What I might want to take, oh, I don't know how I want this done. I want to take 1 over n, right? So if I take x equal 1 over n, and then I take n to 0, what's going to happen here? I'm going to have y equals sine of pi over 1 over n. That's sine of n pi, right? So that's all of these guys, right? Where it's hitting 0, fine. But then what happens if I pick something that is going to end up as sine of pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2? Those are all going to be values of 1. Those are all going here, right? So there's no specific place that it's going. We can say that this kind of function oscillates infinitely. So it's a bit of a mess. But it's an interesting mess. It's an interesting way for this limit not to exist. So if I was, let me just be very clear there, if I write that down of this sine pi over x or 1 over x, sometimes they use 1 over x, this is going to look the same, right? We would just say this doesn't exist. None of the left-hand limit doesn't exist, the right-hand limit doesn't exist, It's just a mess.